Hi folks, welcome back to part 2 of 1.5. And so now we're going to dive a little deeper into this idea of even versus odd functions, okay? In the previous video, we talked very briefly about sort of the symmetry aspect of it, okay? And so just to remind ourselves, the even function is going to have, some symmetry about that y-axis, right? Whereas the odd functions, it has symmetry across the y and the x, or collectively we call that the reflection or symmetry about the origin, okay? And so what I want to do here is I want to draw a point for the even one, and let's talk about where it would go if it was an even function, okay? And so let's start over here. All right, so a random point, and I'm going to call this point x comma f of x. All right, so it's an x value, it's some x value, and I put it into the function f, and then out comes a y value, okay? So where would this point go if it was an even function, if we had that symmetry? This point would get reflected over the y-axis, and it would land right about here, okay? And so let's go ahead and mark that. And this coordinate is negative x, comma, f of negative x. All right. Now, I know that this one is x, so if it's on the other side of the y-axis, it's just going to be negative x, right? Then if I were to count the boxes, this is almost like negative 1.5, or sorry, positive 1.5. And then in the other direction, it would be negative 1.5. Okay, so that's what I mean by x and negative x. And the y values here, f of x, what can we say about this y value and this y value? Well, looks like they're the same to me, right? It's down by this much, and this one is also down by this much. So what we can see here is actually that f of negative x is the same as f of x, okay? So let's write a few things down here. For an even function, all right, we know that this is symmetric about the y-axis, okay? Talked about that, that's not a surprise, so symmetric about the y-axis, all right? But in terms of algebra, how would we write it? We would say f of x is equal to negative f of x, okay? And so that's what we're going to write here. F of x equals f of negative x, all right? And if we think about what this means even, all right, this just means that the opposite x value has the same y value, okay? The opposite x value has the same y value. All right, now let's go ahead and think about this. Same like kind of thinking, but now let's think about odd functions, okay? And so first of all, we're going to draw another random point over here, right? And then we're going to think about where does the point go if it's odd, okay? So this time, let's pick a point. Let's choose this point, right? So this is x comma f of x, right? So it's some x value, put it into the f function, we get a y value, right? And if we were to reflect it over the y-axis, the point would be here. And then after we reflect it across the x-axis, it would ultimately land down here, okay? And so this, we could say, is when we have negative x, and this is our f of negative x, all right? Just like last time, we're thinking about using this general notation. Now, if I look at this, instead of saying symmetry or symmetric about the y-axis, we say symmetric about the origin, okay? And remember, that's when it's both the y and the x, okay? Now, before we said that this point and this point had the same y value, and they do because they're along that same line, right? But this point and this point do not have the same y value, right? If this is a positive 1, then this is negative 1. And if this was positive 11, this would be negative 11, all right? So we say that f of x is equal to negative f of negative x, all right? So it's like the same thing, but negative. So same value, but one is positive, one is negative, okay? And the way we might write that in words, we say that the opposite x value has the opposite y value, right? So this time they're not the same, but they're the opposite. All right, so let's get that back all on one page real quick so we can just think about this. We've got our symmetry that's different, but what we're going to practice now is how do we show using algebra that something is even or odd, okay? All right, so let's take a look at example 1 here. Right, example 1 says f of x is equal to x cubed plus 2x. And when you plot it, you get something like this, right? And we've even got a coordinate here, 1, 3 and 1, -3. So based on this, what are your guesses? Do we think that this is an even function or an odd function? Now, I think most of us would guess that this is an odd function, right, based on the picture, because this point gets reflected here and then again down here. So it has the, let's actually draw them in. It has our y-axis symmetry and the x-axis, okay? So if we had a graph, sure, great, we found that it's odd. But if we didn't have a graph, let's think about how to do this algebraically, okay? So algebraically, we know that if it is odd, that f of x will equal negative f of negative x, okay? So that's what we want to show. So then the first thing we're going to do is to find f of negative x. And all that means is we're going to grab our f equation, and everywhere we see an x, we're replacing it with negative x. Okay, so f of negative x will be negative x cubed, not positive x, plus 2 times negative x. And if we simplify this using what we know about positive and negative numbers, right, we know that a cube or an odd power of a negative number is still negative. And then 2 times negative x is negative 2x, right? Now, after we find f of negative x, we need to make it negative, all right? So find negative f of negative x. And so negative f of negative x is negative everything that we had from the first step. All right, let's simplify this. We get x cubed plus 2x. And wow, if that is not the thing that we started with, I don't know. So what we showed here is that like all of this shows algebraically that f of x is an odd function, okay? So I would encourage you to make sure that you are practicing this piece, okay? I think that most of us probably can see it on the picture, but it's also really important that we can do the algebraic part as well, okay? All right, let's try a second example. We've got f of t equals t to the fourth plus 3t squared plus 7. Now, I wanted to switch up the variables a little bit because I know a lot of times in physics or chemistry, something like that, or biology, we might actually use t for time instead of x. So I just wanted us to remind ourselves that like it's okay if we swap out those x's for t's, okay? Now, looking at this picture, what are your guesses? Even or odd? Like, my guess about your guesses is that if we draw this line in, we can see that like this point gets reflected. This point and this one are reflections of each other. And so it would be a very reasonable guess to say that this is an even function, okay? So the work now is let's see if we can show it algebraically, all right? So algebraically, we want to show that f of x is equal to f of negative x, meaning if we take our x values and make them positive, negative versions of each other, the y values should still be the same, okay? So this one just has one step. Find f of negative x. And let's see. All right, so in this case, let's actually make that a t. So negative t, all right? So f of negative t is negative t to the fourth plus 3 times negative t squared plus 7. And if we simplify this, we see that we have an even power of a negative number, and that's going to be positive. And same thing here, we have an even power of a negative number, so that's also positive. And look at what we have. Our f of negative t is equal to our f of t. That shows us algebraically that this pictured function is even. All right, let's do one last example here. Example 3, we've got g of x equals the square root of x minus 2, all right? Now, if it were even in our picture, if we folded it over the y-axis, then we would see a matching part over here. I don't see a matching part, so I'm thinking it's not even. Now, if it were odd, I would flip it twice, and it would end up with a second part. So this would go here, and then if I flip it over the y-axis, I actually end up with something like this. And now I don't see another part to the function. I only see this part, okay? So it would be a very reasonable guess to say this is neither even nor odd, okay? I did want to show us using some algebra what that might look like, okay? So let's find our f of negative x, all right? So f of negative x would equal square root of negative x minus 2. Now this minus here, all right, means we could really only put in negative numbers, and that would mean we would have something over here, okay? But this is not equal to that. And so therefore, this is not even. Okay. Let's take this second step, and now let's find negative f of negative x. That gives negative square root of negative x minus 2, which gives us negative square root of negative 2 plus 2. And the same thing, this is not the same as the one we started with. So our function is not odd. All right. I did want to just throw one of those in there because sometimes we ask questions and we think, oh, it's either even or odd, but sometimes it's possible for it to be neither. Okay. All right, folks, this is the end of the second part of 1.5. Come on back for part 3.